Hi, hello, good day. Still me, I guess. But for this one, we're going to talk about a new lesson that is related to the previous ones that we have discussed. In particular, we're going to start with differentiating it from linear equations in two variables, because this time around, we are going to talk about linear inequalities in two variables. At the same time, so that we will be able to not overcomplicate things, we're going to automatically connect it to the next lesson, which will be at the end of this particular video, and that will focus on systems or simultaneous linear inequalities in two variables, because this entire thing in particular is not that complicated once you understand what linear inequalities in two variables are. So let's just jump right into it. This particular video itself will be a bit long because it is the entire unit in relation to linear inequalities in two variables, including systems, that will be at the end of this video. So we will start with our first set of learning targets, which is understanding what linear inequalities are by illustration and differentiation. And then from there on, we will continue with more examples. So first, we're going to present the difference of it between symbols, graph, and so on and so forth. So again, our topic is about linear inequalities in two variables. The first thing I would like for you guys to look at is this one right here. So we're being asked about what's the difference of the set A, which is linear equations, and the one in set B of linear inequalities. You have there the same terms that are given, as you can notice, and it is by design, so that you can easily identify what makes them similar and what makes them different. Because at the end of it all, there are similarities amongst our differences. So let's try to process what you guys have been seeing or is seeing right now. So in this case, we can maximize these guide questions. You can maximize the use of GeoGebra if you want to, in order for you to somewhat understand this better. So what you can do on your own, I know it's a video, but it's becoming like an activity lesson, but you may try this on your own while we're in this scene right here. You may try and type y is equal to 2x plus 1 in GeoGebra. Then after that, try writing or typing y is greater than 2x plus 1. So basically, like, try using the same examples but with different symbols. What can you notice in terms of its graph? Was there a difference, or is there a difference? Okay, so in terms of similarity of linear equations and inequalities, it's from the name itself, two variables. So we're still talking about the x and y variable here. And then this is what I'm trying to imply. So what symbols do we use in linear equations in two variables? We simply use the equal sign, right? Kasi nga, the name is equation. So we use the equal sign. But for linear inequalities, you can notice that there is the symbol greater than, there is a less than, there is the greater than or equal to, and the less than or equal to. Meaning to say, in linear inequalities, there are four different symbols, while for linear equations, we only have the equal sign. So there will be a difference you can notice in the graph once again if you try to type it in GeoGebra. So let's try and do that. So I'll make use of y is equal to 2x plus 1 as our example. Okay, so I'll try to type in y is equal to 2x plus 1. Okay, what you can notice in your screen right now is the graph of said linear equation. It simply looks like that, a solid line. So you may simply click the button right here, the dot, so that you will hide it for the meantime. So what if we try naman the next one, which is y greater than 2x plus 1. As you can see here, there is a difference between the two. You can notice that the line looks different, and at the same time, there is a shaded region. So from that alone, you can notice that there is a difference between a linear equation and a linear inequality. So that's what we're going to discuss for this specific video right here. So to continue, what are linear inequalities in two variables? I don't want to go full English on you guys here, but using the prefix in, which means not equalities, So it's basically the definition itself is similar to the definition that we have given to linear equations. The only difference here that is mentioned is all about the symbols. We have four different symbols used here. Now, the thing that I would like to also clarify, in linear equations, when we're doing substitution, identifying ordered pairs on the point, that's actually what we call as a solution. But for linear inequalities, there is a huge difference in terms of its solution. Because the solution of an inequality in two variables is a set of ordered pairs, where it could be the shaded region or it could also include the boundary line, which we will discuss for the specific one. But before we go there, it is important that we know what linear inequalities are and what linear equations are, what makes them different. So for the short activity that we have here, of course, we cannot do an activity because I will not be able to get live answers from you guys, but I'll give you guys the answer here. So we will have certain situations. Let's identify if they are linear equations or if they are linear inequalities. Starting with the value of 1 Philippine peso, represented by the variable p, is less than the value of $1, which is represented by the variable d. We can say that this is p less than d. And this is not an equation because it uses symbol less than coming from this specific term right here. So this is a linear inequality in two variables. To continue, it says here, according to NSO, there are more female Filipinos than male Filipinos. So using the variable f for female Filipinos and more. So that will mean greater than. It's greater than the number of male Filipinos. So this is also a linear inequality in two variables. Okay, so far. So let's continue. The third one we have here, the water level of a river is receding each month. Now, this particular thing is not a linear inequality. It's actually a linear equation. If you remember your previous concept, especially the previous video, that is actually our first item about the receding level of the water in a certain river. And also, what I would like you to understand is that there is no comparison in here. If there is a comparison, that's where we do linear inequalities because you're comparing two sides. While for linear equations, we accept that both sides are equal. I hope that makes it clear. So let's continue. It says here, the number of girls in the band is one more than twice the number of boys. So you might think, oh, there's the word more than. Does this mean the greater than symbol? No. More than could also mean addition. So again, using the explanation that was given from the previous example, you have to understand whether we're comparing things or not. In this case, we're not comparing anything. We're just describing the number of girls, wherein it is again one more than twice the number of boys. So it could be G is equal to 1 plus 2B, or it could be G is equal to 2B plus 1. Either way, it's addition, so it's still correct. Now, if you continue, we have here, Dr. Quinn charges $5 for consultation plus $1 per hour of service. I think this is a linear equation already. We don't have to dwell on it. This is the same example that we had in the word problems. To continue, let's say now that we have Akira wants to gain weight. He currently weighs 120 pounds. His goal is to gain 4 pounds per month. So again, there is no comparison existing in this said given situation, and we're just trying to talk about somebody who's trying to gain weight consistently. So there's a slope there. And also at the same time, again, there is no comparison. So it's linear equation. Lastly, we have the school bus has a maximum seating capacity of 40 people. Now, this thing right here is an exception to the rule. Yes, there is no comparison, but there is a certain term that was used that made this as an inequality. And that is the words or the word maximum. Meaning to say, imagine it like this class. The school bus means that there are 40 seats in there, seating capacity. This means that there could only be 40 people sitting, maximum, but it could be less than that. That's why it's a linear inequality. because you're not required to have 40 people sitting at all the time. What if somebody is absent? So there will be 39 people. So that's the point. It could be less than. So this is actually, if we say maximum, it could be represented as less than or equal to. That's a symbol for that. And that's something that we're going to dwell on as we move forward with these examples. Okay? So now we can actually maximize GeoGebra once again so that we can notice the differences if we use different symbols. So we'll just continue where we left off from earlier and understand what the shaded regions imply. Okay? So I think the example there is y is greater than 2x plus 1. Yeah, let's just make this 2. So it fits the slide. So y is equal to 2x plus 2. y is, sorry, y is greater than 2x plus 2. Then let's type in the other ones. So have y is less than 2x plus 2. Again, you may do it with me so that you'll be able to witness it yourself. The next, let's have, I'm hiding it so that we could see the differences. So let's have y is greater than or equal to 2x plus 2. Then let's have another one. Let's say y is less than or equal to 2x plus 2. And so we're going to start with our linear equation. I want to explain this. So the first thing that you can see here is that there's only one line and it is solid because it is an equation. The symbol used here is an equal sign. Okay, so that's our first thing here. Now, what if we have y is greater than 2x plus 2? As you can notice here, there is a shaded region above the boundary line. And what boundary line are we talking about? It's basically the line itself. And in the line in particular, we can notice that it is not solid, it is broken. Similar with y less than or less than 2x plus 2. The line itself is broken, but now observe where the shaded region is. It is below. If you try out y greater than or equal to 2x plus 2, you can notice again there that the line is solid, but the shaded region is above. And then next, if you have less than or equal to 2x plus 2, the line is solid, but the shaded region is below. It's not complicated, class. You can actually make this easier for yourself by remembering or somewhat using your common sense. If you have the symbol greater than, the word there is greater, this implies that the shaded region should be above the boundary line. And if your symbol is less than, it should be below that. Now, there's something I would like to address to avoid misconception. This could only be sure if your if your inequality is in slope-intercept form, just like what you're seeing on your screen right now. If it's not in slope-intercept form, you cannot automatically say that it is above or below the boundary line. You have to make sure first that your given linear inequality is in slope-intercept form. Now that we have spoken about where the shaded region will be, if it's greater, above, if it's less than, below. Now, what if we're talking about the lines themselves, the boundary lines? If it's just greater than or less than, the boundary line is dotted or broken. But if there is an underline with those symbols, greater than or equal to, less than or equal to, that will be solid. Because from the name itself, equal to, greater than or equal to, less than or equal to. Remember earlier, the first example, we have an equation. Since it's equal, the line that we have is solid. So that's what makes it solid, the equal part. Again, this is read as y greater than or equal to 2x plus 2. And this one is y less than or equal to 2x plus 2. So that's the differences that you can notice in terms of the graph. For an equation, it's just a line. For inequality, there is a boundary line and a shaded region with it. Okay, let's continue. So let's continue and try to graph it using domain and range. So what I'm going to teach you in this specific part of the video is the different ways of graphing linear inequalities. We will have two examples using domain and range, and we're going to have two examples also using slope-intercept form. So by using domain and range, what you have to do is using the inequality, you may pretend as if it is an equation first. You might be asking, sir, why do we have to pretend as if it is an equation first? So that you will be able to form ordered pairs. Okay, that's the purpose of it, in order for us to identify ordered pairs. So for the first one, if you want our x to be 1, we will have y is equal to 2 times 1 plus 2. Again, we're not doing any magic here. We simply substituted the value of x being 1. So to continue, you'll have y is equal to 2 plus 2, because 2 times 1 is 2. So 2 plus 2 is equal to 4. Since your x is 1, and it gives us y being 4, our first ordered pair is found at 1, 4. So it's somewhere here. If we continue, let's make our x equal to 2. Y is equal to 2 times 2 plus 2. So this is y equal to 4 plus 2. We can find our y at 6 when x is equal to 2. So your next ordered pair is somewhere at 2, 6. 2, 6 is somewhere here. And then lastly, let's make it 3. Y is equal to 2 times 3 plus 2. So y is equal to 6 plus 2. Y is equal to 8. So when x is 3, y is equal to 8. That's 3, 8. It's somewhere that we can find here. Now the concern is, what kind of line are we supposed to draw here? Since the symbol is greater than, our boundary line here should be broken. Again, the reason why it is broken is because our boundary line is representing the symbol greater than. So here's our boundary line. Next, where should we find the shaded region? It should be above, because the symbol again is greater than. I'm just going to make it look like this so we could try out test points. So you might be wondering, sir, what do you mean by test points? Test points are basically a random set of ordered pairs that you would like to test whether they satisfy the inequality or not. So let's give it an example. I'll start by giving an ordered pair that is found outside. Outside the boundary line and outside the shaded region. Let's say that I have this point right here at 1, 1. It's not in the shaded region, and it's not on the boundary line. So let's try to figure out if 1, 1 will fit the bill. So all you have to do is use your inequality, which is y greater than 2x plus 2. Always remember, it's an ordered pair, so x comes first, followed by y. Simply substitute that. You will have 1 is greater than 2 times 1 plus 2. 1 will be then greater than 2 plus 2, or 1 is greater than 4. And we all know for a fact that 1 is not greater than 4, so it's false. So here, what I'm trying to explain later, you'll realize what the solution implies. Now let's go and check out a point inside the shaded region. By inside, let's choose the point. I'll choose -1, 2. So let's use that point right here. -1, 2. Our inequality again is y greater than 2x plus 2. Our y is 2 greater than 2 times -1 plus 2. So 2 will be then greater than -2 plus 2. Then then 2 will be greater than 0. So this is actually something that is all we know true. So 2 times -1, -2, add that to 2, you get 0. 2 is greater than 0. That is true. So as you can notice, it is inside the shaded region. Now let us try out a point. Somewhere we can find on the line or on the boundary line. Let's say that I would like to choose the point 0, 2, 0, 2. So using the inequality, I'll have y greater than 2x plus 2. Y is 2 greater than 2 times x, 2 times 0 plus 2. So this will be 2. 2 times 0 is 0 greater than 2. This is false. 2 is not greater than 2. 2 is equal to 2. So as you can notice, what we can summarize here in particular is that since this is broken, the points, sorry, I'll use a different color. Since it's a broken line, the points on the line are false if it's broken. Later, we're going to have a solid one. And at the same time, this is false because it's outside the shaded region. So what I would like you for to understand in this our first example is that we can say that a certain point or ordered pair is part of the solution if it is within the shaded region. And now what we're going to try to understand is when do we say if a point on the line is part of the solution? I think you guys are getting the idea now. So let's proceed with our next example. Let's say that we have y greater than or equal to 2x plus 1. So we will try to solve it again by the main and range. So let's pretend first that it's an equality so that we can identify ordered pairs. So let's do that. Let's have our x being equal to 1. So this is y is equal to 2 times 1 plus 1. So your y is equal to 2 plus 1. Your y is equal to 3 when x is equal to 1. So your first ordered pair is at 1, 3. To continue, how about if x is equal to 2? 2 times 2 plus 1. Y is equal to 4 plus 1. Y is equal to 5. So y is 5 when x is 2. So you have 2, 5. Lastly, you have y is equal to 2 times 3 plus 1. Y is equal to 6 plus 1. Y is equal to 7 when x is 3. So your point is at 3, 7. So we can plot all these points 1, 3, 2, 5, 3, 7. And now, as you can notice, the symbol is greater than or equal to. So our what do you call this? Our line should be solid and not broken. Let me just use a ruler right here just to make sure that it is straight. And is it straight now? So your line here is, oh, hindi siya straight. Wait, let me just bring it down a little. Okay. So it's gonna be a solid line because again, the symbol is none other than greater than or equal to. So the shaded region should be above because the symbol is greater than or equal to. So let's try to use test points again. If it's outside, let's try 2, 2. So outside we have 2, 2 as our example. That's our first ordered pair. So using the inequality again, y is greater than or equal to 2x plus 1. Substitute that, you'll have 2 is greater than equal to 2 times 2 plus 1. So 2 will be greater than or equal to 4 plus 1. 2 will be greater than or equal to 5. And that is false. Now let's try a point inside the shaded region. Let's say, let's say 0, 2. It's within it. So let's try that one. Let's have 0, 2 as our test point. Using the inequality, y greater than or equal to 2x plus 1. Let us substitute 2 greater than or equal to 2 times 0 plus 1. This is y greater than or equal to 0 plus 1. Or simply y is sorry, why am I saying y? 2. Sorry guys, sorry. 2 greater than or equal to 1. And this is true. Apologies for that. I was using 2, then I said the y again. Why did I go back? I already substituted. And then lastly, what if it is on the line? I think you guys are understanding it now. I hope so. If it's on the line, let's try to use the point that we have anyway. Let's try to use 1, 3 as an example. So if you continue with that, you'll have y is greater than or equal to 2x plus 1, where y is equal to 3, greater than or equal to 2 times 1 plus 1. So 3 is greater than or equal to 2 plus 1. Or simply, if you put it into perspective, 3 is greater than or equal to 3, which is actually true. Now you might be wondering, how is this example true? Because the symbol implies greater than or equal to, meaning if that is the case, the points on a solid line, since this is solid, the points are also part of the solution. The points on the line are also true or are also part of the solution. Either way, they're both correct naman. So if it is solid, the points on the line are part of the solution. But if it is broken, it is not part of the solution. So that's the difference between the first example and the second example. So if you notice here in the first example, it's greater than only, meaning if it's broken, the points on the line are false. But if it's solid, the points on the line are true because they are part of the solution. Okay? So to continue, here we have another example, but this time around, we're gonna have um, a linear inequality that is going to be graphed using slope-intercept form. Apologies for the lag in my voice. I know this is a video, but my co-teachers are asking if I want some coffee, so I have to say yes to that. Apologies. I'm not gonna edit this out. I have to stay true to my true colors. Coffee is life. Anyway, let's use our given 10x plus 5y less than 15. For everybody who's listening and watching this particular part, I would like you to understand that graphing linear inequalities or equations can be done in numerous ways. Today, I'm presented already how to graph using domain and range. This time around, I'm going to present how to graph it using slope-intercept form. So what you have to do first is to put it in slope-intercept form. I think we have done it already in writing linear equations in the previous video. Now, what I would like you to understand is this. Um, excuse me. You may use transposition, the technique, or the properties of equality. For this video in particular, I will be doing properties of equality instead. But again, it's the same case as transposition, wherein if you transfer one thing to another, it will change signs. Again, the transposition came from the properties of equality. So the goal here is to isolate the y variable. Isolate it. Okay, so how do we do that? If we have 10x plus 5y, I have to eliminate the 10x here. Since it is positive, I will subtract 10x to both sides. So continuing, I will now have 5y less than negative 10x plus 15. Okay, why is it negative 10x plus 15? Because you cannot subtract negative 10x and 15, right? You cannot do that. So what you can do is simply combine them together. So in this case, we already have the y variable isolated as a term, but it still has a visible numerical coefficient. So you don't have to make it complicated. Divide the entire thing by whatever it is next to the y variable, and that is 5. Doing so, we will have 5 less than negative 2x plus 3. Why did it become negative 2x? Negative 10 times, negative 10 divided by 5 is negative 2. 15 divided by 5 is 3. And again, I made an error. Ang galing-galing talaga ni Sir Alcantara. Great teacher, as they say. 5y divided by 5 is supposed to be y. Okay? So now it is in slope-intercept form. Never mind the symbol. So this implies that your slope is negative 2, and then your b is 3. Now, what particular part do you have to remember here? There's a certain note there that remember that the y-intercept is obtained by having x is equal to 0, meaning to say your ordered pair will be represented as 0b. Meaning, in this example, your y-intercept could be found at 0, 3, since your b, again, is equal to 3. So what will you do there? You will simply use that as your first ordered pair or first point. This is 0, 3. Now, what do I do next? Well, go back to your slope. Your slope is negative 2. This is the same as negative 2 over 1. Always remember, class, if you have a slope, an m equal to negative 2, it's the same as having negative 2 over 1. All integers, positive or negative, are over 1. Always remember that. If you want to convert them as a fraction. Sir, why do we have to put these things as a fraction? Because we want to maximize this said slopes in order to identify other points on the graph. In order to do so, we're going to go back to the concept of rise over run. So the rise over run, again, is the formula to get the slope. And since the slope is negative 2 over 1, your rise is negative 2, your run is positive 1. So if it's rise and it's negative, that means we're going to go down by 2 units. So from 3, 1, 2. Because your rise is negative 2. And since your run is positive 1, you go to the right by 1 unit. Meaning, your next point should be found here. And since you already have 2 points indicated, you can already draw a line. But here's the concern. The symbol here is not greater than, not equal to, but just less than. So what you have to do is when you draw your line, it has to be a bit broken. Again, why is it broken or dotted? Because the symbol is less than. Apologies, I used the ruler but it's still not straight. And since it's less than, where can we find our shaded region? It should be below the said number line. Below. So that's how it works. Since the symbol is less than, below the number line, below the boundary line. I'm stuttering na guys, sorry. But that's the point. Again, using the slope-intercept form, identify your y-intercept, and then using the slope, identify the next point, and then graph it. So that's how it works. So let's continue to our next example. Let's say that we have here um, 3x plus 4y less than or equal to 15. So similarly, what you have to do is to put this in slope-intercept form first. 3x plus 4y less than or equal to 15. Let us subtract 3x to both sides because we want to isolate the y variable. So we're going to have 4y less than or equal to negative 3x plus 15. And again, to isolate your y variable completely, divide the whole thing by whatever it is that is next to it. What is its numerical coefficient? So you'll have y less than or equal to negative 3 over 4x plus 15 over 4. So you might be wondering, sir, it's fraction. So what you can do, the thing that you can do here best is to estimate. So 15 over 4 is the same as 15 divided by 4. So you'll have 3 times 4, that's 12, and 3. So meaning this could be 3 and 3/4. That's the answer here. Meaning you can find it somewhere there as an estimation. The only time that I would like for you guys to think of fractions is, or somewhat mixed fractions, is to estimate in the graphing part. So we know that our slope is already a fraction. We have no problem with that. We can easily identify the rise and the run. But our b is at 15 over 4. That's 0, 15 over 4. For us to graph that properly, you should know that it is in 3 and 3/4 to be exact. So it's in between 3 and 4. So it's somewhere here. So since your rise is negative 3, you go down by 3 units. 1, 2, 3. Then it should be somewhere there. Then your run is positive 4. So 1, 2, 3, 4. So your next point should be somewhere here. And then the next thing that we're going to do is to draw a line. And since the symbol is less than or equal to, it should be a solid line because it's less than or equal to. Next, apologies for the super straight line. Since it's a solid line, the points on that very line should be included. And then the shaded region should be found somewhere below. The reason why the shaded region should be somewhere below, because again, the symbol is less than or equal to. I hope that makes it clear. So that's how you graph it so far. So you have two options. You may do domain and range, where you give out values of x and identify the corresponding values of y. The next one that you can do is by slope-intercept form. So that will be it. So to generalize this one, here is the situation. When you're given a linear inequality or linear inequalities in two variables, you have the symbols greater than, the boundary line is dotted or broken, the shaded region is above, and the solution or the true answers are only is only the shaded region. Same with less than, but the boundary line is still broken, and the shaded region now could be found below. But if it's greater than or equal to, this is the indication class. Since there is a line below it, just think of it like that. That's one thing that my students said to me, like, oh sir, if there's an underline to the greater than or less than symbol, which implies equal to, the line should be solid. So you may look at it that way also. And since the symbol is greater than, the boundary line should be next to the shaded region above it, while if it's less than, the shaded region should be below it, just like that. And for these two things in particular, since they include or have the equal to in their description, the shaded region and the boundary line or the line itself are part of the solution. So this alone, this slide right here, if you get what they mean, you're good to go. You don't have to worry that much anymore. Again, what I'm trying to emphasize here, what makes the symbols different with one another and what makes them similar. So you have to take note of that. Okay. Um, I was thinking of making this just a one-part video, but it's already 35 minutes. So I think I have to stop here. So this is part one, I guess. So you may pause for a second. I don't know. Maybe I'll just put them all together. Who would watch a 1 hour video? Well, I guess you can still skip anyway. Yeah, it's hard to edit this one out. Why am I babbling? This is rest time, I guess. You don't have to do this, or you may try this on your own. This is not required, of course. You're not my student. I don't know. Are you my student? Who knows? But you may try this on your own to understand it better. Again, try to somewhat identify their differences in terms of definition, solving, graphing, and real life application. So I may use that as a way for you to practice. But again, of course, I cannot require you in a YouTube video. Why would I do that? Like, how would you submit your output, right? So just use this as a practice. Now let's continue for our second part. This time around, we're gonna verify test points also, just like earlier. But this time around, we're gonna focus more on that. So again, a linear inequality in two variables. Same standard form as linear equations, but the difference is the symbols that we're using. We have greater than, less than, greater than or equal to, and less than or equal to. Okay, so this is the test points thing that we have been doing earlier. So it's given that we have x plus y less than 3, we can simply do substitution. It's an important skill that you guys have to understand. So how do we verify? We know again that it's an ordered pair. You have x coming first and followed by y. So this means that x is equal to 0, y is equal to 1 in this given. So by substitution, you will simply, again, do not make this complicated for you. Your x is 0, your y is 1. So you will have 0 plus 1, and it's less than 3. So 0 plus 1 is equal to 1, and it's less than 3. And we know for a fact that this is true. But what if we have this given right here? Again, remember an ordered pair is xy. This means that our x here is 2, our y here is 2. So doing so, we will have x plus y less than 3. Substitute 2 plus 2 less than 3. We're going to get 4 less than 3. And that is false. Because 4 is not less than 3. It is greater than 3. That's why it's false. So what I'm trying to say here, in order to verify, you don't have to make it complicated. You may simply substitute. And in this case naman, we're going to show how to verify points. You have two options, whether by substitution or by graphing. So let's do that. So let us verify by substitution with this example here. So you have the same case, x plus y pa rin. But now let's try negative 2, 5. So our x here is negative 2. So negative 2 plus 5 less than 3. Your x is negative 2, your y is 5. So negative 2 plus 5, that's 3, less than 3. And this is false because 3 is supposed to be equal to 3. To continue, yeah, let's have here x is negative 1 plus another negative 1 less than 3. So negative 1 plus negative 1 is negative 2 and less than 3. And we all know for a fact that all negative numbers are less than positive numbers. So this is true. Okay, that's how easy it is. You don't have to make it complicated. Let's have another one. Let's have 3x plus y greater than 10. Let's just substitute that. So you'll have 3 times 0 plus y, which is also 0, greater than 10. So as you can notice here, everything will be 0 anyway. 0 plus 0 greater than 10. This will be 0 greater than 10. And that's not true. So that is false. Next one, let's have 3 and 2. So you're going to have 3 times 3 plus 2 greater than 10. So 9 plus 2 greater than 10. That's 11 greater than 10. And we know that this one right here is true. Now let's continue. This one is a bit different. How do we identify or verify points if they are true or false based on graphing? So we have to look at first our given. We have x plus 2y greater than or equal to 8. Let us first isolate the y variable by subtracting x to both sides. Minus x minus x. So we're going to have 2y greater than or equal to negative x plus 8. Divide everything by 2, just like earlier. Then we're going to have y is greater than or equal to negative 1 half x plus 4. Always remember, class, if you have a negative x or an x, like for example, if you have x, this is the same as 1x. If you have a negative x, it's the same as negative 1x. Okay? And the reason why we're separating the negative x and making it negative 1x so that we can easily identify the slope. So the slope here in this example is negative 1 half, meaning our rise is negative 1, our run is 2. The y-intercept in this example, 8 divided by 2, so you're going to have 4. So your ordered pair is found at 0, 4. Okay, so that's our first point. Let's graph that 0, 4. And then again, since our slope, the rise is negative 1, go down 1 unit. Then the run is 2, go right 2 units. So you now have 2 points. So what you have to do next is to draw a line. Since the symbol is greater than or equal to, it should be a solid line first. So let's have that. Let me use color yellow. Ayan. So we have our graph right here, and our shaded region should be found where? Should be found above because it's greater than. So it should be here, this entire thing. So if you do graphing to verify, you have 0, 5, which is found here. It's in the shaded region. So this is true. 0, 5 is true. 5, 2 is somewhere here. It's also true. Negative 1, 4 is somewhere here. It's false because it's outside the boundary line and outside the shaded region. 4, 2 is also somewhere here. So it's also true. And if you wish to do it by substitution, you may. And it might take a while, but the answer will be true anyway. Our line here is not that straight, but if you look at it, 4, 2 could actually be found at the line itself. It's just the line isn't straight like some of you guys. Just kidding. Don't bash me. Anyway, let's continue with one more example. Let's say that we have x plus 3y less than or equal to 6. This time around, what we have to do again is put it in slope-intercept form first. Doing so, we'll subtract x to both sides. Again, if you wish to do transposition, that's your choice. Same answers will be received anyway. Negative x plus 6. Divide the entire thing by 3. So you will have y is less than or equal to negative 1 over 3x plus 2. So your slope is negative 1/3, and your rise is negative 1, run is 3, your y-intercept is 2, your ordered pair is at 0, 2. So you go there, 0, 2, go down 1 unit, negative 1, then go right 3 units, 1, 2, 3. So that's where your second point will be found. Draw a line. Since the symbol is less than or equal to, you have to have a line that is solid. So let's have a solid line. And again, since the symbol is less than naman here, less than or equal to, the shaded region should be below. And now let's verify the points. Let's have 5, negative 1 somewhere here. And it's actually true. It's within the shaded region. 2, 2 though is somewhere outside. So that is not a solution. Negative 1, 3 is also outside. So that's not a solution. How about 4, 2? 4, 2 is somewhere here. It's also outside. So it's not part of the solution. Remember again, it's part of the solution if it's within the shaded region. And if the line or the boundary line is solid, if it's on the line, it is part of the solution. So that is it. That's how you verify if the given test points satisfy the linear inequality by graphing. And the previous one is by substitution. So now, while we're at it, it's already 45 minutes in. Why not just go for it, right? Let's now go on with our last part of this discussion. And we're now going to focus on word problems involving linear inequalities in two variables. So let's have our first in linear inequality word problem. It says here, a clothing manufacturer has 1,000 yards of cotton to make shirts and pajamas. A shirt requires 1 yard of fabric, and a pair of pajamas require 2 yards of fabric. It takes 2 hours to make a shirt and 3 hours to make the pajamas. And there are 1,600 hours available to make the coating. So one of the most important things to point out here is that what are the variables? Meaning, what are we talking about here? In particular, we're talking about making shirts and pajamas. So those are our variables. So to make this uniform, I will make my X as my shirts and I will make my Y as pajamas. Now, the concept here that we're going to talk about now is no longer just one linear inequality. We're going to have two. And that's why you might be looking at this like, this gets a bit confusing. Like, how is a system different from just a linear inequality? When we say system, in some references, we call them simultaneous, meaning there is more than one given. So, how do we identify or write said linear inequalities in this example? So, we're going to look at the context. So, that's how we're going to work at it in the beginning. So, what are the two contexts or situations that are in this given word problem? The first one that we could look at is the amount of yards that we need to use. You have 1 yard and 2 yards, and you have a total of 1,000 yards in here. So that's where you start with for your first inequality. You have 1,000 yards as what you have all in all, and that means that you're going to use 1 yard of fabric for a shirt. So you could write that as 1x or x as a whole. And then for pajamas, you need 2 yards. So you're going to have 2y. So the context in the first situation is by the yards or the materials. So what kind of symbol should we use? It just said there that a manufacturer has 1,000 yards. This implies that that's the maximum amount of yards available, meaning the manufacturer could use all of that, or the manufacturer could use less than that. So that's why the symbol for this one is less than or equal to. I would like to repeat. The reason why it's less than or equal to is because there's a specific amount of yards available. And again, you could use all of that or less than that. It could not be greater because you only have 1,000 as a whole. Similarly, what would be our second linear inequality? Other than the yards, what else is being talked about here? The hours. Wait, I'll use a different color. I'll just use yellow. So we have hours, 3 hours, 2 hours, 1,600 hours. So you'll start with at the end, 1,600. And always remember, class, the context is important. So you have here hours. So you should not have x plus 2y symbol then 1,600 because x plus 2y refers to the yards. So you have to be consistent. What refers to the hours here? You have 2 hours and 3 hours. Since shirts is being represented by x and 2 hours, you'll have 2x. And since you have pajamas represented by y and it takes 3 hours to make them, it will be 3y. Now, what symbol should we use here? Since it says here that there are 1,600 hours, that means that it could be equal to 1,600 or it could be less than that also. So the symbol is less than or equal to. So as you can see here, the two linear inequalities that we have are given already. Now you're trying to figure out, sir, what do I do when I have like two linear inequalities now? When we're talking about systems, you have to graph it. So since some of you guys are either my face-to-face students, some of you guys are maybe at home as my online distance learners, or maybe some of you guys are not even my students at all. So depending on your situation, you might be required to do this manually or maybe through a graphing tool. So again, what you have to tap in here, please listen carefully, is that you may use the skills that was previously explained earlier. So you may use the slope-intercept form, or you may use identifying ordered pairs by domain and range in order to graph said linear inequalities. Okay, so because it's gonna take us a long time if we're gonna do it all one by one. So let's just say I will turn them all first as slope-intercept forms. So I have x plus 2y less than or equal to 1,000. I will isolate the y variable by subtracting x to both sides. So I will have 2y less than or equal to negative x plus 1,000. Divide the entire thing by 2 in order for me to isolate the y variable completely. So the final linear inequality will be y less than or equal to negative 1 half x plus 500. Okay, so the line here will be solid because the symbol is less than or equal to. The y-intercept is 500, something that can be found at 0, 500. And the slope is negative 1 half. Rise being negative 1 and the run being 2. While for the second example, what we can do here is we can have 2x plus 3y less than or equal to 1,600. So subtract 2x to both sides. You're gonna have 3y less than or equal to negative 2x plus 1,600. Divide the entire thing by 3. And we're gonna have our final inequality as y less than or equal to negative 2 over 3x plus 1,600 over 3. Do not be worried. In the examples naman that I'll give in our class, it won't be this complicated. So we know that it will still be solid because the symbol is less than or equal to. Our y-intercept could be found at 1,600 over 3. In ordered pair, that's 0, 1,600 over 3. Our slope here is negative 2/3, where our rise is negative 2. Our run is equal to 3. So the thing here is that what you have to do is to graph them together in one Cartesian coordinate plane. So that's the one that I'm going to show to you next. So once you have identified the linear inequalities, once you have written them, you have to graph them properly in just one Cartesian plane. So let's go there. Let's go to a new version of GeoGebra. Let's have the first one as, I hope I remembered, x plus 2y less than or equal to 1,000. Am I correct? And then the next one is 2x plus 3y and we want this to be less than or equal to 1,600. Ayan. So what I would like you to understand here is that you okay. I'll hide it first. I'll show one muna. So I'll make the color of this one different so that you can notice the difference, and then I'll show the next one, the linear inequality that we have. Let's make this green. Okay. So when speaking of systems of linear inequalities, what you have to do is to graph them on the same thing. Doing so, you will see something like this. Ayan. So you might be thinking, sir, what happened? You don't have to overcomplicate it. While you're looking at it, when you have only one, it looks like this. But if you have two on the same Cartesian plane, they are overlapping with one another. So as you can notice here, the two graphs overlap in the certain region here, where it's not just plainly red or green. And that means that for a given system, the solution of it, the ones that will be true, should be the same for both. Meaning, if you do or verify points, it should be true for the two of them. Okay? That's what I want you to understand here. When we're dealing with systems of linear inequalities, it should be the set of points or ordered pairs that are within the shaded region where both inequalities intersected or overlapped. But since this is a word problem, you have to make sure that when you try to identify test points, it fits the situation. Know that it is impossible to have negative number of shirts or negative number of pajamas. So when you're dealing with word problems in particular and not just graphing, you have to make sure that you answer them correctly. Basically, if it's a word problem, most of the time, the solution are or is found at quadrant 1 only, where everything is positive. Okay? It may include 0, but the rest is positive. The negative numbers are not considered for most word problems is because, again, there's no such thing as a negative number of pajamas or a negative number of shirts. So this is how systems look like. So I hope you understand why I did not separate the creation of the video for systems and the linear inequalities, because at the end of the day, they're the same thing. It's just that you draw them at one or in one Cartesian coordinate plane. Okay, so for the first example, I'll show the GeoGebra version of it, the graph, but for the rest, you may try it on your own. It's not supposed to be complicated anyway. I'm just gonna show you the process on what to do and how to write the said linear inequalities, and then that will be it. So just to verify or somewhat clarify certain concerns, you don't have to overcomplicate it. In some cases, even in other teachers, they specify which one would be X and which one would be Y, because you may interchange them. You may interchange the representation. And at the end of the day, based on the context of your representation and labeling, the answers will still be correct as long as you do the correct process. So, for example, here we have a radio station is giving away tickets to a play. They plan to give away tickets for seats that cost $10 and $20. They want to give away at least 20 tickets. The total cost of all the tickets they give away can be no more than $280. So, in here in particular, the confusing part for some students when they're reading something like this is like, what are the two things that we're talking about here? There's just tickets that is mentioned. Then, you have to dwell on that. Since we're talking about tickets, are we just talking about one kind of ticket here? No. We're talking about two kinds of tickets for two different kinds of seats. We have the cheaper and the more expensive version. So since we're talking about tickets for seats, we can make our x variable as our cheap seat and the y variable as the expensive seat. So that's what we can do. So in this case, the first inequality that we can have would be in line with the prices, and the other one would be at the number of tickets. So why is that the case? So why is the first one the number of tickets? Because it is mentioned in this word problem that there will be at least 20 tickets to be given away. So we can start with that. So 20, and the word is at least, meaning that's the minimum. The number of tickets to be given can be above that. And the word above that implies that it should be greater than or equal to. Okay, above that. Now, in this case, we have greater than or equal to 20. What we can do next is complete the entire inequality. To what will you compare it to? Well, basically, we'll write x plus y greater than or equal to 20. I would like to give my explanation here as clear as possible. For most systems, we write x plus y. There's a pair of x plus y there, paired to each other and to a certain given. The reason behind this is because we're talking about a certain number of things. We're talking about here the number of tickets for seats. The difference between this example and the previous one is that the previous example, there's measurements. Here, there's none. There's no specific restriction. We all know that there are two kinds of tickets. So the total of it could be represented by x plus y. Okay? So later you will see something similar. To continue, other than number of tickets, the next context that we have is about the money, the price. The price in total, or the total price. Price or prize, well, same concept because it's a prize anyway. So we have here as $280, and since the word here is no more than, meaning it could be 280, but it could be, excuse me, it could be less than, but it could not be greater than that. Kaya nga, no more than. That's why the symbol that we're going to use here is less than or equal to. So that's the case here. Now, what do we do next? How do we write the rest of the inequality? Since we're talking about prices, we'll go back to the $10 and the $20 that we have here. We know for a fact that if it's $10, that means that's the cheaper version, right? The cheaper. So that implies that we have 10x for the cheaper seat and then 20y for the more expensive one. I hope that is clear. So what you can do again, in order to graph this, you may simply put them all in slope-intercept form. So let's subtract x to both sides, and you will have y is greater than or equal to negative x plus 20. So that's your first inequality. Y is greater than or equal to negative x plus 20. It is solid. The y-intercept is 20, found at 0, 20. The slope is negative 1. So that means your rise is negative 1, your run is positive 1. Next, you have the second one, which is 10x plus 20y less than or equal to 280. So isolate the variable y by subtracting 10x to both sides. You're going to have 20y less than or equal to negative 10x plus 280. Divide the entire thing by 20. So you're going to have y less than or equal to negative 1 half x plus 14. So this is still solid. Your y-intercept can be found at 14 or 0, 14. Your slope is negative 1 half. Therefore, your rise is negative 1. And your run is equal to 2. So again, you may try to graph this on your own so that we could save time for it. So with that, again, draw it on top of each other, and you will see that there is a region wherein they're intersected. There's some cases wherein they will not have an intersection, so you have to be careful where you put the shaded region. Okay, so let's have one more example, I guess. One more. So we have here our inequality. You can work at most 20 hours next week, and you need to earn at least 920 pesos to cover your weekly expenses. Your dog walking job pays 75 pesos per hour, and your job as a car wash attendant pays 60 pesos per hour. Write a system within your inequalities to model the situation. So we're talking about jobs here or your work. So let's make our x variable as our dog walking job, like the number of hours we spend with that. Okay, just complete the thought. And then for y, let's talk about your car wash attendant job, the number of hours that you give into it. So there are two contexts that we have to take note of in this example. The first one is all about the hours you're supposed to spend. So number of hours that you can spend. So we can represent that as, again, 20. But the word there is at most. At most means that it could be 20 hours and less than that, but it could not be greater than 20 hours because that's the maximum hours that you can work. So your symbol here should be less than or equal to 20, because again, you cannot go above the 20 hours of work. So how do we complete this? Since you can work at the most 20 hours, and we have the x and the y for like the amount of hours you spend for those works, this is the one I was mentioning. It will be x plus y, because again, we're just basically getting the total number of hours that you're gonna work for that certain period of time. Now, the other context that was mentioned here is all about the money. You have 75, you have 60, and you have the 920. And here it says at least 920. So this is about the salary that you can get. The word is at least, meaning it could be greater than it or equal. Using the pattern x plus y, what should you multiply to x, which is your dog walking job? You get 75. So 75x. Again, the reason why it's 75x because you get paid 75 per hour of your dog walking job. While for car wash attendant, you get paid 60 pesos. Why did I say dollars? Oh, sorry, pesos. So 60y. And that's how it looks like. Again, you don't have to make it complicated all the time. Just remember that labeling and context is important. You cannot combine the two. You cannot relate 75x plus 60y to hours because we're talking about salary. Then why are you going to go talk about hours in the same inequality? That's inconsistency. So you have to be consistent with what you're talking about here. So to continue and have x plus y less than or equal to 20, subtract x to both sides, you're going to have y less than or equal to negative x plus 20. So that's your first inequality. Y less than or equal to negative x plus 20. The line is still solid. The y-intercept is 20, so the point is at 0, 20. The slope is negative 1, so the rise is negative 1. The run is positive 1. Then for our next inequality, we have 75x plus 60y greater than or equal to 920. So we subtract 75x to both sides. We will have 60y greater than or equal to negative 75x plus 920. Divide the entire thing by 60. So we're going to have y is greater than or equal to, I think this will be negative 5 over 4x. And then this would be somewhere like 92 over 6. So you may still simplify it if you want to. So the line here is still solid. The y-intercept is 92 over 6, which can be found at 0, 92 over 6. Again, you can still simplify that. Then the slope is at negative 5 over 4, meaning your run is negative 5. Your run is 4. So again, you may continue with that one, graph it, and that will be it. And finally, last example. We have John is packing books into boxes. Each box can hold either 15 small books or 8 large books. He needs to pack at least 35 boxes and at least 350 books. So we will write a system of linear inequalities to represent the given situation. So doing so, we're talking about here about the boxes that we're collating. So he's packing kasi the boxes, diba? And there are books in there. So what you can do is, let's talk about x being the number of boxes with small books. And then the next one is the number of boxes with large books. So that is our x and y. So the first situation here, in the context of boxes, again, just like earlier, the word there is at least 35, so greater than or equal to 35. So we'll have x plus y greater than or equal to 35 because, again, we're just talking about the total number of boxes that will be used. While for the second context, we have 350 books. So total books is the next context that we have. Doing so, we have 350 at least. at least 350, so greater than or equal to 350. So what will you do with the 350? How will you represent the small books? Since there are 15 small books per box, it will be 15x. 8 large books per box, so that will be 8y. So that's how it works. And again, just like earlier, put them all in slope-intercept form, greater than or equal to 35, subtract x to both sides. You're gonna have y is greater than or equal to negative x plus 35. So that's your first linear inequality. So this is still solid. The y-intercept is at 35, 0, 35. Slope is negative 1. The rise is negative 1. Run is positive 1. So for the next inequality, you have 15x plus 8y greater than or equal to 350. Subtract 15x to both sides. You're going to have 8y greater than or equal to negative 15x plus 350. Divide the entire thing by 8. And then you're going to have y greater than or equal to negative 15 over 8x plus, what is this if you simplify it? 175 over 4. So this is still solid. And then the y-intercept is at 175 over 4, 0, 175 over 4. Your slope is negative 15 over 8. So rise is negative 15. Then your run is at 8. So since this is the last example, let's try to graph it on the Cartesian coordinate system. So let's do that. Okay. I hope I still remember it. Wait, let me just erase it. So our first one is found at x plus y greater than or equal to 35. And then the next one that we have is at 15x plus 8y greater than or equal to 350. So as you can notice again, there will be a part where all of them intersects. That part right there represents the possible situations. So since it says at least, you start with 35 there as the point wherein the books, number of books, I guess. So this is how it looks like when they intersect. And meaning all of the possible options or possible combinations will be found at the shaded region where again the two linear inequalities overlap. And we are clocking in at already 1 hour and 12 minutes. Good luck with us. That's it. And I hope you guys understand this better, hopefully. And that ends the entirety of linear inequalities into variable, including systems of it. And that ends our video lesson for today. Please take note of all the skills, techniques, and all of the details that you need to master in order for you to understand these concepts clearly. Some of these lessons you don't have to really memorize everything, but you just have to embody the skills, master it, practice it, and then with that, everything's gonna work well. And in case you don't see me, always remember, good morning, good afternoon, good evening, and good night. Peace out. Respect.